Hello, my name is Jim Brain from Retro Innovations, and today I want to demonstrate a project I've been working on for a couple weeks. The seed for this project was planted at the Vintage Computer Festival Southeast in Atlanta, Georgia earlier this year, 2017. At the show, there was an exhibitor who had a plethora of Texas Instruments systems. I've seen a number of Texas Instruments systems, such as the TI 994A, and the peripheral expansion box, along with the TI 998, which they had pictures of. However, there was a portable machine there that piqued my interest, the Compact Computer 40 from Texas Instruments, or CC40. And talking to the exhibitor, I found some interesting things out about this particular machine. It was frustrating to the exhibitor about the CC40, or has limited the usefulness of the CC40 over the years, because there were a number of peripherals that were promised and prototyped for this particular unit, but were never produced. The unit includes one peripheral expansion option for these bus peripherals, or one peripheral expansion bus called the Hex Bus. The Hex Bus is well known within the TI community because it was also an interface bus present on, I believe, the TI 998, and did have a prototype interface built for the TI 994A. However, the peripherals for this particular bus either were produced in very low quantities or were prototyped and not produced at all. So here is a Compact Computer 40 unit. As you can see, it is a rather small unit. I would say approximately 2/3 the size of a Tandy Model 100. However, it does not have nearly as large of computer screen. Now it does have a ROM and battery-backed RAM location here, but unfortunately the only other expansion option is the Hex Bus, which is right here. The Hex Bus connector is essentially, with the exception of the cartridge port, your only expansion opportunity for this particular machine. And because of the lack of peripherals for this machine and the inability to save programs any other way, has limited the usefulness of this machine. So I thought it might be interesting to see if I could implement a rudimentary interface using this particular Hex Bus interface, or bus interface. So this particular unit is interesting because of the bus and the fact that there are not very many peripherals, but there is a significant amount of technical documentation on the Hex Bus. It is a 4-bit or nibble based bus it's clocked, but it shares many similarities with the bidirectional bus capabilities of like I2C, which is a serial bus that many people will recognize. It has open collector outputs so that either side can drive the bus low, and then of course there are some handshaking capabilities within the Compact Computer 40 or other systems that have the Hex Bus interface. Later on, TI resurrected the Hex Bus in the form of what's called the Dock Bus, which is part of the TI 74 and I believe the TI 95 calculator line. So one of the things I thought about doing is implementing a small solid-state hard disk or floppy disk drive for the CC40. And for that, I decided I would do an SD-based drive using the FAT file system. That would give users the opportunity to store programs on their SD card directly from their PC or Macintosh, and then pop the SD card into an interface and use those programs on the Compact Computer 40. So here I'm going to show you the contents of my SD card right now. And so here are some programs that are stored on an SD card that I found online that were written for the Compact Computer 40. And you can see many of them have PGM after their name. This one right here is a test program that I will show you in just a minute. So that's what's on the particular SD card, and now I'm going to show you the interface that I've prototyped. So here is our unit, the Compact Computer 40, and I'll get some light on here so you can see it well. And then I'm going to show you the interface. So this is the small interface that I've built, prototyped for the Compact Computer 40. Currently it's self-contained, and it uses an Atmel AVR Mega 168 as the microcontroller, and there's just a small number of additional parts on the board. You know, the SD connector here, and then the 16 megahertz crystal, and two small capacitors that are used to trim up the capacitance on the crystal. And then let me bring it in just a little bit further here so it's easier to see. So then you have the actual microcontroller itself, the Mega 168, and then right over here there are 6 resistors. They are set up as voltage dividers. The SD card interface is a 3.3 volt system, and the AVR is currently running at 5 volts. Also, right over here is a 3.3 volt regulator, a smoothing capacitor for the 3.3 volts. Over here is a smoothing capacitor for the 5 volts, and then this itself is the Hex Bus connector, which is a 2x4 connector, standard pin header, and it is obviously on 0.1 inch centers. Underneath the unit is some wiring, obviously, and currently I have the unit running from 2 coin cells, which provide 6 volts of power, and I have a 5 volt regulator right here, and a switch right here to turn the unit on and off. So let me put the interface, or the SD card that I just showed you, into the unit. This is just a sample card that I had laying around. And let me bring the unit back out here so that you can see the whole system. So we have the unit itself, and then we plug in the interface cable. Right now I don't have a Hex Bus cable, so I am using just a regular IDC cable, and I do have an adapter to bring the connection a little further outside the unit so that I don't have to worry about trying to get it out of the unit. So we will put the unit right there, and we will turn it on, and then we will turn on the computer itself. And so first of all, what we're going to do is we are going to clean out all of the memory and list the memory here, and then we are going to load a program. Now in this particular case, we're going to load from the disk drive, and a program you saw earlier called One, which had no file name extension, and it is loaded. And so here is our simple Hello World program. So that's not very interesting, but there are some other programs on there that are interesting. Again, we will clear out the program memory, and then we will load let's see, got a little bit of glare there. That should make it a little easier. And the unit should load at about 10K per second. It takes longer because I have a lot of debugging turned on right now that sends data out to the AVR serial port. And so I've got the unit slowed down enough so that all of that data can be transmitted out. But as you see here, we have successfully loaded Mastermind, and we can run it. And there you go. So another thing that you can do with the program is you can save. So we can save the program that we have here, mastermind.pgm. clean out the memory, and then we can load master mind.pgm. And again, it runs faster than this if debugging is turned off, but for this particular prototype and demonstration, I think speed is the primary concern. Again, here's the same program. So this should allow people to load and save programs from the CC40 as well as the TI 74 Basic Calc and the TI 95. The unit may also work on a TI 99-8A or the TI 99-4, the TI 99-8 or the TI 99-4A with the prototype Hex Bus interface. But yet, as I don't have either one of those, I can't test. So this is the unit. It is not completely functional yet. It does not support some of the additional commands available, such as catalog and being able to handle relative files and so forth. But since the basic protocol was in place, the rest of it should come very quickly. Hope you enjoyed the demonstration.